going on, everybody? Welcome to trèSci Weekly, episode 27. I'm one of your hosts, Jonathan Ullman, alongside future Planetary Protection Officer Tom Kea.
What's up?
What's going on, my man?
Thanks for having me, as always.
My pleasure. Thanks for being here. Kyle Kalita off camera, running the camera, running the show back there. Mush, co-pilot, next to him, as always. Chris, making a shake in the kitchen. Kayla playing Zelda on the couch. We're getting more viewers, Tom, but they're viewing.
They're live.
They're live, right? This is insane. How we doing?
Doing well.
Good.
We got a library program coming up on Wednesday.
Yes, we do.
Still talking about the eclipse. It's almost here, finally.
I know. We've been doing nonstop talking about the eclipse, so that's good stuff. Wednesday night, 6:30 p.m. at the Patchogue Carnegie Teen Library.
It's a separate building from the Patchogue Medford Library.
Yeah, so really beautiful library,
It is,
by the way.
It is sweet.
Yeah, really nice. So if you guys are in town on Wednesday night and want to stop by, you're more than welcome to join us. Program's about an hour long, and
it's learning with fun and not tests.
Exactly. Although I will quiz you at the end.
Oh.
No, it should be good. There should be some clear weather, so we'll get to take the solar telescope out, I'm hoping.
Yeah, that'd
Maybe
be nice.
see some sunspots. I don't know if there are any sunspots, but that'd be awesome. Woohoo! We got Harrison in the chat. Good to see you. Welcome. Hope you're well. Hope all of you guys are well out there. If this is your first time checking out trèSci Weekly, welcome to the stream. This is our weekly video podcast where Tom and I discuss science news that trending topics in science news that are kind of making their way across social media, and doing our best to explain them to you guys as we can, doing the best job that we can. We're no experts,
giving you the ins and outs of our research that we've done.
Absolutely. You can catch this show live, as you are all doing right now, on Monday nights at 8:30 p.m. Eastern Time. You can also, alternatively, watch the show on our YouTube channel for free, as it goes up there pretty much immediately after we do the live show. It would really mean a lot to us if you would subscribe to the channel. If you like this video, give it a thumbs up and chat with us there. You can also follow us on Facebook at our Facebook page, facebook.com/trèSciWeekly. Check out some of the supplementary things that we put up as far as like additional stories and adages to what we talk about on the live show. And we also have a Twitter that you can follow us on, twitter.com/trèSciWeekly. And Tom's pretty much at the helm of that account, sharing and liking and retweeting different topics that we are going to discuss.
Yeah, and I finally got on my Twitter where I have my Twitter and trèSci's Twitter, and I could go in between the two of them.
Nice.
So now I'll finally be able to use it how I want to.
Awesome.
Took me forever to figure that out, but we're good now.
Sweet. Yeah, I don't know how to do that, so maybe you can teach me. So we encourage you guys to chat with us during the show. Any questions or comments or concerns that come up, feel free to chat with us there. And we have patreon.com/trèSciWeekly.
That's a lot of fun.
Last one, in case you were feeling extra generous with the financial donation, you can go to patreon.com/trèSciWeekly and pledge us any dollar amount there. We really appreciate that if you do decide to go do that. And a quick shout out to our patrons from last month.
It's a new month already.
It's a new month. So so big thanks, big shout out to Dan Smith, Andy Dunscombe, Juan Gonzalez, Ryan Nash, and your mom, Tom.
She's a nice lady.
Very nice lady.
All right. So before we get into the stories, we were just talking about the eclipse that's coming up in 2 weeks now. We're doing the program. Any other stories that we're not talking about that you've heard news of?
Any other stories?
Before we get going? Or should we just jump right into it?
I'll make a note about it, but this was the 5-year anniversary for the Curiosity rover.
Yeah, we're going to be talking about that.
Yeah, so we'll make a mention of that, but there was a cool video that NASA shared that you guys should all go check out. Kind of just talking about the accomplishments that Curiosity has made so far, and I thought that was pretty interesting. So we're not going to explicitly talk about that, those accomplishments, as it were, but we are going to talk a little bit about Curiosity rover today.
Yep.
Anything else on your end, Tom, that you saw?
I don't think so.
Cool. Well then, one more quick thing before we begin. Today's my mom's birthday.
Oh, nice.
And Kayla's dad's birthday. So big
double birthdays.
double birthday, yeah. Happy birthday! Shout out to my mom and Kenny Riley. So yeah.
Cool. All right, let's get right into this week's stories.
Let's do it. Here we go. Number one, Tom. This big one.
All aboard!
For the first time in the United States, scientists have successfully corrected for a genetic mutation using CRISPR-Cas9 editing techniques in human embryos. The mutant gene targeted, known as MYBPC3, can be responsible for an enlarged heart condition and sudden heart failure. The researchers, led by Shukrat Mitalipov of Oregon's Health and Science University, report that 72% of the embryos, quote, induced double-strand breaks, or DSBs as they put it, at the mutant paternal allele, and were predominantly repaired using the homologous wild-type maternal gene instead of a synthetic DNA template, end quote.
So what they're saying there is that they cut out the mutated gene that could cause the heart failure.
Mm-hmm.
They took that out and then replaced it with DNA from a maternal, so from the mom, and then put that correct DNA into the spot where they cut out the mutation they didn't want in there.
Absolutely. Yeah. So they, I guess what they weren't expecting was that happens somewhat naturally, right? That use the maternal DNA rather than the DNA templates that they had injected in,
Mm-hmm.
because they knew what they wanted to correct the gene to be, and so they threw in those kind of smaller copies of that gene in there, but the actual embryo just took the information from the maternal gene,
Use that information and then
to copy over. So that was somewhat unexpected, right? So this point came as a surprise to the research team, since editing genetics usually requires a template for DNA repair mechanisms, and suggests that using the mother's healthy gene may be evolutionarily advantageous.
So even though it was kind of unexpected, this might be a better way to go off trying to do this.
Right.
And when you're going to take out something, putting in the healthy version from the hereditary person you're getting your DNA from in the first place seems like it's kind of a good idea.
Yeah.
Right? You're taking it from the source, so you know it's going to work in that sequence.
Yeah. Now, I don't know, Tom. I don't know whether they mean that this is evolutionarily advantageous for humans, right? Because this is now one of the first studies done with actual human embryos. So I don't know if that's where the surprise come from, where it's like, okay, well, when we test this in mice, we have to provide a DNA template because otherwise we cut out the mutant gene and it doesn't know what to replace it with.
Mm-hmm.
And here we're saying, well, no, in humans, we don't even really need the template because the mother's
replace it with the
gene is there to copy that information from. So that's kind of interesting. Like, did humans evolve that way on purpose?
No, of course not on purpose.
Well, yeah,
but yeah.
You know what I'm saying.
That just became a thing, I guess.
Interesting. So it also suggests that CRISPR-Cas9 may only be ineffective if there isn't a healthy gene from either parent to use when making DNA reparations, right? So if the mother's DNA was also had the mutation at that section,
then they would not have been able to do this.
Right. I mean, I guess it remains to be seen whether or not that information would have still been copied from the mother,
from the DNA template,
or from a DNA template that is correcting for it. I guess there must be ways for them to force it to correct, right?
Yeah, but I guess it's not as efficient, or as, it doesn't work 90-something% of the time. I guess it's just a way that you can kind of influence it, I guess.
Interesting. Yeah. Interesting. And it may also suggest, Tom, that designer babies, one of the big concerns with CRISPR-Cas9, may not even be possible if an embryo preferentially chooses to repair its DNA based on what's available to it from its parents versus taking in a trait via an outside source. right? So if what we're seeing here is like, all right, well, the template DNA is not even being used to correct for the mutation once the mutation is cut out with CRISPR-Cas9, well then it's certainly not going to work in the sense of like, all right, well, we're cutting out your gene for blue eyes and we're going to replace it with green eyes, because that would be a new trait, right?
A new piece of DNA being added.
Yeah, and so if it doesn't look like that's the case here, well, then maybe that would never be the case, and
yeah, you might just not be able to do that. I mean, I'm sure down the road there's a way to do everything.
Yeah.
But not in the near future. It doesn't seem like that's the way it's going.
Yeah, that's a good point. The researchers also point out that they were able to reduce the number of mosaic embryos, or embryos with a mixture of repaired and unrepaired cells, down to just one by injecting Cas9, the enzyme used to make cuts in the DNA strand, alongside the sperm. Right? So previous experiments saw Cas9 injection 24 hours post-fertilization, where 13 of 54 embryos turned out to be mosaic, and according to the study, no off-target Cas9 cutting was found in an analysis of the genome, though some critics of the study state that not enough of the genome was sequenced in an unbiased manner to confidently state this. Right, so let's unpack that a little bit here.
Yeah, there's a few things to go over there. So the first thing that we mentioned was that in this experiment, also what they did was give the CRISPR-Cas9 system to the sperm, so that before the cells started to divide, they had the information in the sperm, as opposed to adding it in later down the road. It gets the gene as soon as fertilization occurs.
Right.
So what might be the advantage of getting that as soon as the starts occurring?
Yeah, so that basically makes it so that there's not a chance for the mutation to be copied, right, to the embryo. So
yeah, so I guess when you give it with the sperm, you get it right away into the embryo.
Yeah.
So then it has no chance. Yeah, anything that divides, it has that in it.
Right. Kyle, we actually have a graphic that is probably useful to be up while we're talking about this.
Throw up the graphic.
I should have cued you before I said this. So, yeah, so we're seeing that the old way of doing this, maybe in prior experiments, right? CRISPR-Cas9 gets added kind of at step 3 here, and that can lead to mosaic embryos where
some of the cells have the change and some don't.
Exactly, and that's just overall probably less of a healthy situation for a growing embryo. And now what we're saying is like, all right, so we're going to add CRISPR-Cas9 right as soon as we add the sperm.
So as soon as the embryo forms, then it'll take these changes along with it, and that seems to be the case.
Yeah. Now, they did still find that there was one case of mosaicism, even with doing this. So it's not a foolproof method, and I don't think that they really designed the experiment to figure out what is happening at the cellular level that is leading to a better estimation of uniform embryos.
They don't know exactly how it works, but they know when you give it with the sperm initially, it's a way better just way to do it, basically.
Yeah, and the logic makes sense there, right? Don't give the zygote a chance to copy the wrong information.
The wrong DNA that you don't want.
Right. And then what we also said was that there was no off-target cutting found. So, Tom, what does that exactly mean, off-target cutting with the Cas9?
Yeah, so whenever you're replacing DNA, you have to make a cut into the DNA itself, right, to cut it and take out what you want. So the question is, does the CRISPR-Cas9 system recognize only the parts that you want it to cut, or does it make other cuts that you might not know about, or know that it would make those cuts, and what implications would that have on the DNA?
Right.
So it's not just like this easy thing where you send it in. It's sort of like a biological machine, and you don't really know exactly how it's going to go through it all the time, because we don't really know that completely yet.
Right.
So that's a lot of the critique. They said in this particular experiment, they took a lot of effort into looking at off-site cuts, more than they did in past studies, but people still say they don't do it enough in general.
Right.
So they claim that they looked at a lot of off-sites and that the Cas9 didn't go in there and just cut random sequences, but people still say you need to be stricter and look at everything.
Yeah. So ideally, the entire genome would be sequenced in order to see if there was any random cutting that they didn't intend for, but so far so good.
Yeah.
Right? So they looked in places where they thought it might happen, and it didn't happen. So that's a step in the right direction. Finally, it should be noted that the authors of the paper unabashedly hope to bring CRISPR-Cas9 gene editing closer to a clinical setting, but not before all the details are fully understood. Currently, the FDA is prohibited from reviewing applications for any procedure that would introduce heritable changes in human embryos. An image credit for the image that we showed goes to the study, H. Ma et al. In Nature.
Mm-hmm.
So, yeah, I thought that was kind of an interesting way to close the paper, is that they're really pushing for clinical trials to happen with CRISPR-Cas9.
Yeah, so this was the first time this was done in the United States, really?
With human embryos.
With human embryos, yeah.
Yep. Yeah, I mean...
And then it does seem pretty crazy, but one thing that we talked about before the show was that this particular gene was sort of the easy gene to go after, where if you were to try and do this study in the embryo, this would be the one that you would suspect to work the best. Right. Is what the people who made comments about this study were saying.
Sure.
So
yeah.
This is like the ideal thing to change and go after and see if it makes the change, right?
Yeah. And I don't think that there's anything wrong with that, because you can look at this as a proof of concept. Like, you know, you got to start.
This idea works.
You got to start somewhere. So to be optimistic about it is, I think, totally okay. You know, like we all want this to work because we all want to cure genetic mutations that lead to, you know, disease.
Just horrible situations.
Yeah, horrible situations right out the gate. And so this would be a nice kind of, I don't know, way to start it with good news, right? You know what I mean? Like, let's not proclaim that it's just dead on arrival, because then that gets it into the public opinion and this goes nowhere, right? The CRISPR-Cas9 it dies. So I think it's okay that they started with a well-researched, computer-simulated genetic defect, and were able to find some success with it. I think that's great. Question from the chat. Harrison asks, doesn't the CRISPR system have a self-correcting algorithm to fix any undesired mutations that may occur?
Yeah, so it kind of does have the ability to fix a mistake, but what we're looking at isn't really like a mistake in copying the DNA or anything. We're looking at just, is it cutting your DNA in other spots? Like, it's not really a mutation or a mistake. It's just the way the system works. When you want to cut something out of the DNA, the way your biological machine cuts, it's going to cut other places as well. That's just what happens when it recognizes that sequence. So it can't self-correct for that, because it just, when it gets the cut code, it cuts. You know, that is what it is. Yeah. But I'm sure there's some way to make that more precise as this progresses down the line.
Yeah. And like we said, I mean, this is just further proof that what they expect to work works, right? Mm-hmm. So, I mean, we've done lots of studies in mice, and then, you know, very closed off situations that didn't include actual humans.
Yeah.
And now the next step is like, all right, well, cool, we have a way to make this work how we intend to do it, and as long as nothing catastrophically goes wrong, we can do it. We can reproduce the same results in human.
Begin doing these clinical trials more and more, basically.
Yeah. So, I mean, we'll see where clinical trials end up, right? How far out they really are.
But yeah, they do still seem pretty far away.
Yeah. This is an optimistic study, but yeah, I think that, you know, as with all science, it's careful to tread the water slowly. Right?
Yeah.
Cool. Moving on. Number 2. NASA has recently posted a job opening for a Planetary Protection Officer.
Is that a good way to pick up chicks? I'm a Planetary Protection Officer.
That's what Chris Pratt does, man.
That's what he does.
So, I mean...
Guardians of the Galaxy.
Yeah.
Works.
The full-time position is open to the public with salaries listed between $124,406 US to $187,000 US per year. It's a lot of money, Tom.
It is. It's a good job.
So get your resume ready. According to the usajobs.gov listing for the NASA gig, quote, this position is assigned to Office of Safety and Mission Assurance for Planetary Protection. Planetary Protection is concerned with the avoidance of organic, constituent, and biological contamination in human and robotic space exploration. NASA maintains policies for planetary protection applicable to all spaceflight missions that may intentionally or unintentionally carry Earth organisms and organic constituents to the planets or other solar system bodies, and any mission employing spacecraft which are intended to return to Earth and its biosphere with samples from extraterrestrial targets of exploration. This policy is based on federal requirements and international treaties and agreements, end quote. Tom, what does that mean? Because I've been seeing a lot of stuff on social media sites about somebody becoming the defender of Earth from aliens.
Not quite, right? Not quite.
I mean, it is in there.
Yeah.
But it's not exactly that, right?
Yeah. So maybe alien life forms, like microbes and things like that. So really what we're talking about here is when we bring stuff to other planets, rovers and whatnot, even if it's just a robot or a machine, we have a chance to introduce our own biological matter. And then on the flip side, when you bring stuff back from Mars, you want to make sure that you do it the right way without mixing life forms and whatnot.
You might get a Calvin situation.
Yeah, if you've ever seen the movie Life, I guess that's worst case scenario. I guess.
So this is interesting because I often think about this, like when people are like, "Oh, is there life on Mars?" The answer is yes, because we put it there. Like there are some
microbes from the Mars rover on the surface of Mars.
They've
been there for a little bit.
Yeah.
Even if they didn't exist in that environment. There has been life on Mars for a tiny bit.
Yeah, since at least the 1970s.
Since we put rovers on.
Yeah. But this raises an interesting question, Tom. Right? So why is NASA looking to pay someone a 6-figure salary for this position? Well, it turns out contaminating Mars with bacteria from Earth is already a huge concern and actually a point of contention between research groups and administration. NASA's Curiosity rover, who we mentioned earlier is celebrating a 5-year anniversary of successful landing, is currently restricted from visiting specially designated locations where microbial life that has hitchhiked a ride from Earth to Mars on board the rover might be able to persist and thrive. As Curiosity makes its way up Mount Sharp, the central peak within Gale Crater, it has identified possible recurrent slope lineae, or dark streaks that indicate possible seasonal water flow. I have an image for Kyle to throw up showing you what those streaks look like. So you can see them there. They think that this might indicate some seasonal flow, right? We know now that there is confirmed water on Mars. And so, yeah, what produces these dark streaks?
This might be a spot where there's surface flow of liquid water on Mars. And that's the pickle that they're in, right? Is do we send our rover here to where there are possible microbes? Because that's the whole point of this, right? We're trying to find the life.
Yeah.
So you'd want to send it there, right? But then this is an argument against it. Like, this is exactly where you should go if you want to find life.
Right.
If there's liquid water flowing on the surface, you got to check it out.
But the problem is, right, the Pickle Rick, Tom, is that if there is some microbial life still existing on Curiosity's rover,
you're putting it into these water conditions.
Yeah, it may, be able to live there, right? And now there's just microbes that exist not on the rover, but like on Mars.
True.
Just chilling.
Just a quick add-on. I read from other scientists making comments that the surface of Mars right now is not hospitable to Earth life at all.
This is
so
true.
It probably would not exist there, even if we somehow got some microbes into water. like it's not nice conditions on Mars right now.
Right. So I mean, that's the big
It's
push.
not all hunky dory, so we should probably check it out, right?
Yeah. So we should probably check it out. I agree with you. But the other thing, Tom, is that if there is native Martian life there,
you don't want to.
We don't want to give them smallpox.
Yeah.
You know what I'm saying?
And just fudge it all out.
Yeah. So that would be really, really bad. And this is all that a planetary protection officer has to
take
think
into
about.
account and then make up policies and figure out what should we actually do. How big of a risk is it really? So, I mean, I guess this takes a lot of research and figuring out what the odds are and weighing all the pros and cons and everything.
Yeah, and there's a lot of, this is administration in NASA, so there's a lot of weighing the budget of future missions that are like, all right, well, we could make it so that there are absolutely no microbes on board the next Mars rover.
Yeah, we actually didn't bring that point up yet, is that we do know how to completely sterilize it before we send it over.
We've done it before.
We've done it before. It's just that it costs a lot of money, and you don't want to cut your money from all your other different type of experiments and things you want to put on it, spending all that money trying to sterilize everything.
Yeah.
But yeah, that's where we're at.
Yeah, so if you think you're up for the job is open to the public. So you can send your resumes to NASA. Of course, I'm sure it's not going to be an easy gig to
get
secure.
A job at NASA, yeah.
But yeah, we'll see. I mean, somebody's going to become the next planetary protection officer. Although there is already a chief planetary protection officer.
There is right now.
Yeah. I think her name is Cassie Conway, maybe?
Yeah, and they made
Something
it seem
like
like she's going to have competition now or something.
Yeah.
I'm not too sure.
We'll see. Shaking up the administration over there. Kara Kalita in the chat says the Stony Brook Geosciences Department was founded by Professor Schaefer to study the moon rocks, which were kept in a safe in the building. So I'm sure returning those lunar samples, they probably underwent a whole thing with the planetary protection officer, right?
About what you can and can't do and what steps you need to take to keep these specimens to the highest caliber of unperturbing them or whatever.
Yeah, for sure. So yeah, I mean this made the rounds on a lot of websites as being like a silly thing, like somebody's going to protect Earth from space aliens, but like no, it's a pretty prestigious
practical
position.
job,
Yeah, very something that we should all consider because it's imminent that we are
We're going to Mars.
Yeah, and return samples to Earth as well.
That's the next plan.
Yeah, absolutely. Number 3, speaking of anniversaries, while Curiosity is celebrating 5 years on Mars, NASA's Voyager mission is celebrating 40 years of exploring space, Tom.
It's a long time.
40 years, dude. Yeah, God bless. To mark the occasion, NASA is inviting the public to tweet submissions of a 60-character or less uplifting message using hashtag #MessageToVoyager, of which members of the agency will then vote upon and select one message to be sent across interstellar space toward Voyager. And I like how they phrased that Tom, because they're not actually saying
it to it.
Yeah,
but we're going to send it to it. It'll eventually get there, right?
But does Voyager have the capabilities to receive like just a random 60-character message?
I don't think so.
I don't think so. So they're just like, yeah, we'll just send a message in its general direction, and
because it didn't have those capabilities back then. That's kind of a funny thing,
right?
To advertise.
I also thought it was pretty funny that the way they're going about doing this is that the members of NASA are going to vote internally about some possible messages to send to Voyager, not just allow the public to vote, because we all
pick it,
we all see what happens when you let people do their thing on Twitter.
It would be ridiculous.
Yeah,
who knows?
If you're interested in making a submission, you can post your messages on Twitter, Instagram, Facebook, Google+, or Tumblr. Submissions must be received by 11:59 p.m. Pacific Time on August 15th, 2017. JPL, NASA, and the Voyager team will select their top picks. The public will then choose the winning message by a poll from these top picks. And so I thought it would be funny, Tom, to throw in some of the Twitter replies that I saw on Twitter. Yeah, so Kyle, if you wouldn't mind bringing up some of these Voyager messages here. First one, send nudes.
Oh, typical.
Typical, right?
Typical. Internet.
Next one,
pull my finger.
pull my finger. Very appropriate. Very, very classy move, right? And the third one that I thought was kind of funny. Are we there yet? Are we there yet? Are we there yet? Sounds like Kayla when we're driving somewhere in the car. So annoying. No. I'm just kidding. I only say that because she's right there. So, what do you think, Tom? You got any uplifting messages to send to the Voyager mission?
So what I was thinking is, did you read that thing on Twitter that Tyler tagged us in about when we first discovered quantum computing and we sent a message to Voyager?
Yeah.
You read that, right? That was pretty crazy.
Yeah.
About actually sending a message to Voyager. We can tweet it out. It was really interesting.
Yeah, we should.
But that's a different side story. Really cool thing that Tyler, who was on the show, shared with us on Twitter. Kind of like this what if type of scenario. If we finally learned how to communicate with Voyager after not being able to for all this time, what would Voyager think and feel? So it's kind of a weird thing because it's just a computer, but
I want to know, man, I can't remember what it was called.
But we'll tweet it out and put it on Facebook. It was really cool.
Yeah.
But anyway, that was really cool. I haven't seen anything like that in a while. I don't really know what I would send in my message to Voyager.
Yeah. I mean, it's doing its thing.
Yeah.
So it doesn't really need a whole lot of uplifting messages. I do like how NASA tries to like personify the robotic spacecraft missions now. Like
that each machine is like a mini.
Yeah, like they have their own personalities and like characteristics about them. I think that's kind of cool. But, you know, at the end of the day, like it's just this thing that's flying around interstellar space. So,
and like we said, we're sending the message at it, so it's not like anything's receiving it there either.
Yeah. So
it's not going to send back thanks. Like you can't even do that.
And you could just go out in your backyard and probably yell into the sky, and it's basically the same thing, right?
It's similar.
Similar. Number 4, Tom. On Tuesday, August 1st, 2017, the VIRGO detector, based just outside of Pisa, Italy, has joined LIGO in the search for gravitational waves. And we've talked about LIGO quite a bit, actually, on numerous occasions here on trèSci
about
Weekly.
Like the first official detection of gravitational waves.
Yep.
That's when we mentioned them, like previously on trèSci.
John Locke is a gravitational wave detector. VIRGO consists of 2 interferometric arms, each 3 kilometers in length, similar in design to LIGO's 2 detectors, which are 4-kilometer arms based in Livingston, Louisiana, and Hanford, Washington. Adding VIRGO to the pair of LIGO detectors will make pinpointing the source of gravitational waves much more accurate. So that's kind of exciting because right now I guess you can triangulate
between the 3.
Yeah, between the 3 detectors. So whereas the 2, you just kind of get a time difference, right?
That's very slight.
Yeah.
But yeah, this is quite a larger distance, so with the more distance, it's easier to pinpoint exactly when it is and where it is, right?
Yeah, and I imagine it's similar in trying to figure out the spatio-temporal region of where
it came from.
Where it's coming from. It's similar probably to how they detect the epicenter of earthquakes.
Yeah, you need 3 stations, right?
Stations.
To triangulate it.
Exactly.
Same sort of thing, but in space to find out where those gravity waves came from.
Yeah. Now, I don't know that that's how they do it for sure, but I imagine...
They take out their compass, they draw 3 circles,
yeah.
Like, there's the black hole. It's that easy.
It's that easy.
Not quite, but...
Data collection for VIRGO's first official science run will continue until August 25th of this year, when all 3 detectors afterwards will undergo operations to further improve their sensitivity to gravitational waves. Image credit. I don't know if Kyle put any images up while we were talking about that stuff, but
we can put up an image.
Yeah, it was just some like, you know,
of what it looks like.
Yeah, of what like VIRGO looks like. Yeah, it's the building with 2 long interferometric arms there, and one of the tubes, kind of the subterranean tubes that they've got with the lasers.
Yeah, so any type of these things exist inside of these tubes for the exact conditions you need, right? They keep it the exact temperature they need, the exact electronegativity.
Yeah.
They take everything into account, put it in those tubes, and then it's super sensitive to measuring what you want, and it's isolated from outside disturbances.
Right. Right. So yeah, because any slight perturbation to
literally someone walking above it.
Yeah.
Yeah.
The lasers, what it's kind of pointing at. I mean, that's how they're measuring this, right? So these things are moving, not even the diameter of a full atom, right?
That shift we were measuring is so small.
Yeah, but they must be pretty confident that the conditions wouldn't lead to any other perturbations. So that's pretty cool. Caracolita in the chat asks, do these waves travel through the Earth like neutrinos? So my answer to that is yes and no. They do propagate through the Earth so that the entire Earth kind of experiences this little wave ripple, much like a neutrino passes, gets spit out from objects in space like the sun and just pass right through the space in between atoms on Earth. However, a neutrino is a particle. It's a thing that's just so small and so non-interacting that it just
passes right through everything
without
interacting with anything.
Right, whereas gravitational waves are passing through us probably all the time, but they're so far away and their energy is so dissipated by the time they reach us here on Earth that the wave front perturbs only just a very, very small amount, like almost nothing, to the point where
we need these super large detectors to measure these minuscule perturbances.
Yeah. We would, as humans...
But it does have some sort of interaction because we're measuring it, right?
Exactly, yeah.
And we have managed to change the conditions and catch a neutrino too, right? As they're passing through in certain neutrino detectors.
That is true. Actually, that's what I should have said at the top of the show. I did read something about a new neutrino detector.
Oh, okay.
That is like only yay big, right? Like, whereas they've built facilities underground with slabs
they look like pools, right? With all these balls in it and everything.
In order to try to detect neutrinos in the past, and now something about, really kind
something more practical.
Yeah. Quaint ways to detect neutrinos. I wish I knew more about it, but I just did not have the time to do a full research.
We might be able to talk about it next week.
Yeah.
Possibly.
We'll check it out.
It's funny, in the movie 2012, they just say, neutrinos have started interacting with matter on Earth, and now everything's heating up, and now it's the apocalypse. And they just don't say how that's possible, they just say it.
Yeah.
It's pretty funny. It's a pretty funny premise for the movie.
A lot of bad science in Hollywood, isn't there?
Yeah, not the best movie either. But.
Tom, number 5. According to the National Survey on Drug Use and Health, a survey of over 50,000 people conducted in 2015 results estimate that 91.8 million adults use prescription opioids, with 11.5 million reportedly misusing them and 1.9 million reported a misuse disorder. Those are troubling numbers there, Tom.
Yeah, it's a lot of people.
Quote, more than 1/3 of U.S. civilian non-institutionalized adults reported prescription opioid use in 2015, with substantial numbers reporting misuse and use disorders. Relief from physical pain was the most commonly reported motivation for misuse. Economic disadvantage and behavioral health problems may be associated with prescription opioid misuse. The results suggest a need to improve access to evidence-based pain management and to decrease excessive prescribing that may leave unused opioids available for potential misuse, end quote. So, Tom, I thought we would share that with everybody just because this is a growing health problem in the United States. And as somebody who deals with chronic pain and yet opts to not take any prescription opioids, I thought that you might be able to shed some light as to what the situation is really like out there.
Yeah. So I guess where to start for me would be that that's a lot of people. 91.8 million adults is what they estimate. So that's like almost 1/3 of all people. And then these are adults, so you gotta take into account that they're not prescribing opiates for the younger group. So it really is like a ton of people. It's like half of all people almost.
Exactly.
That have been prescribed it. So I think where it was that sort of led it to get to the bad point was that this was the only real way that we said if you take this, you'll see less pain, right? It was the only evidence-based medicinal type approach to controlling pain management. So it became, it's approved by the FDA and everything, and you can prescribe it to people, and it sort of was like the option for a long time, just, because it's kind of like a crappy situation, right? We're not saying this is just going to make your life better. The whole point is that you're in a tough spot, and this is something that provides relief.
Mm-hmm.
And then that was sort of the only thing that was there, so it just became widespread used, and it was given to everybody because pain encompasses so many diseases and afflictions and things like that, where it's not really used ideally to treat it at all in long-term use.
Right.
So we've gotten to the point where it was given to all these people because it was what people felt like were the only option. But now we're here seeing the effects of it and saying, is this really worth it? Like, this is the solution we've given to all these people as the best option. Is it really the best one? I mean, obviously no. Hopefully, as we go down the future, we see better medications and better options available.
Yeah. Alternative solutions, and maybe solutions that haven't even been pioneered yet, right?
Yeah.
So, yeah, I mean, it's such a tricky situation because, as you said, opiates provide a guaranteed, form of relief for many people, right? It's just like, oh, you got a tooth extracted? Well, here's some pain meds, some opioids.
Subside,
yeah, just to help that work out. And I guess that's probably what a large portion of this 91.8 million
prescribed for it the whole year. They
right.
were giving it for X, Y, or Z.
Exactly. Yeah. But do you think our reliance on opioids has just gone way off the rails here? I mean,
yeah,
it is something that your body forms a dependence to. It just is. It's what heroin is based off of. So, where did that happen? What do you think? Where did that route to, to pain management, where did that go down that road? And
of prescribing this for a longer period of time.
Yeah.
And just knowing that's sort of the way it works. So it's weird when you think about saying people can get addicted to this, and saying a percentage of how many people do. But when you think about it, it sort of makes sense, right? You're taking something that's relieving your pain, and then as you take it for a longer period of time, it doesn't work the same way. And all you really want to do is relieve pain, so it's just a natural thing to form a dependence on.
Yeah.
It's just something that generally happens to people who use it over a long period of time.
Yeah.
So, I mean, I feel like we should be moving away from this, but as we'll transition this into Tom's Corner at the end of this, just talking about the future of this kind of stuff, it's imagine there was a better solution, right? That there was, you take this pill instead and it relieves your pain but doesn't cause XYZ. You know how much money's in that?
Yeah.
So when you really think about the transition from the major mode being opiates, that relieves pain the best across a large range of situations, to coming up with something else, that's a pretty big transition, right? With money and agencies and what we're making and how we're distributing it and all that. So I don't really see anything on the frontier of this is going to replace it, right? And I've read quite a few things, but it seems that we now, everybody knows that this was sort of a bad situation, but now that we're saying that it's kind of hard to swallow the pill that this is a crappy situation being prescribed opiates for a longer period of time, but we don't have a good alternative solution out there. It's kind of a crappy place to be in. So it feels like we're almost in the gray area of transitioning into something else, but we don't know what that really is yet.
Yeah.
So some people are still clinging on to this as the only option.
Interesting. So, you can almost look at it, from my perspective, as the same sort of dependency that our nation has on fossil fuels, right? And now there's a breadth of new energy solutions that we might be able to try
pursue
out.
And
But right now, it's like, well, yeah, but we still need oil, you know?
Because there's a lot of people driving cars and
Yeah.
whatnot. Yeah.
So, like, yeah, we would like to maybe find some alternative pain management solutions because there is a problem with opioids. Not that they're going to run out like fossil fuels, but there is a health problem with them, but we still need them, right? Overall.
At this point in time, yeah.
I think that's maybe a way to think about this whole thing. So, Tom, that's all the news that I have for this week. But you said we have a Tom's Corner that will maybe tie this whole week together in a sense.
So it's sort of a quick one. I just wanted to use we were thinking into the future with our first story about CRISPR-Cas9, and we're trying to think about what the future might look like with us changing embryos and everything, as well as at the end, what might be the future of treating one of the largest issues, especially in the United States, is with pain and opioid uses. Where is the science going, and is it going to offer the answer or safe haven, or is it going to be this long, jargony and filled with policies and all this transfer of who owns the industry and how long is it really going to take?
Yeah.
So when we're looking into the future, we can start with the first one with CRISPR-Cas9. It sort of seems to redefine almost what it means to be a person when you know you can sort of change the inner workings of you, right? It's like, how really special am I and how individual do I want to be when there's options to sort of streamline you in a direction that leads into a way that works for everybody.
Yeah.
See what I'm saying a little bit?
I see where you're getting with that. I think that that's maybe the broad, I don't even know if I want to use the word appeal, but like kind of the broad mentality of what CRISPR-Cas9 can do, right? It's like, wow, we are really on the brink of like being able to just edit everybody's genetics to be one uniform superhuman that is
template.
That is totally resistant to like getting sick from genetic mutated diseases and like can just perform, you know, like it's just totally awesome.
It's pretty crazy.
It's pretty crazy to think about, but I also think that that's where the policies need to come in and basically say, well, no, like we can't just use this for building a super person out of, right? Like we need to only restrictively use this for maybe eradicating disease.
Yeah, so I guess it would sort of go down like things would get on a list, like you can edit out for, maybe the first one will be the degenerative heart disease because it's the easiest studied and most well-known one.
Right.
Maybe eventually down the line. And they might eventually add things on that you'd want to correct.
Exactly, yeah. So, yeah, you start picking and choosing, like, cool, we can use CRISPR-Cas9 to
do
effectively
X, Y, and Z,
erase this genetic mutation. And then, like, that gets taken care of from here on out. And then, like, all right, well, now we've done a bunch of studies where, cool, now we can, repair
Weed out
for
this part of
osteoporosis or whatever it ends up being, right? I mean, osteoporosis isn't a genetic mutation, mutated disease, with. Yeah, but by the same token, right? Yeah, I don't know that we need to be alarmed by CRISPR-Cas9 yet. I don't think that that's really where we're at.
I kind of agree with you on that. And then just looking into the future of that, it's sort of the same application with thinking about opioid uses. What does it look like down the road with the research that's going on now, and what might the possibilities be? So I've read a few articles saying that they're trying to come up with a new non-steroidal anti-inflammatory, which is basically like ibuprofen, just a different kind of one they're trying to come up with. So I guess you can sort of use it as an ibuprofen, cycle it with an ibuprofen, things like that. So there are some things down the road that are on the radar, I guess, with treating pain stuff, but nothing really out there that if you have a type of surgery or something, we know a different way besides using opiates to lower how you feel pain. There's nothing really that good on the horizon. And like I was saying, that would be so much money and such a change to the industry of being able to treat so many people for so many reasons with this sort of pain relief.
Right.
And I think when something finally does come along that seems like it's definitely the way better alternative than opioids and we should go that way, it's going to be, even though we know how crazily bad the situation is right now, it's still going to be a slow transition.
I think you're right, yeah. Because...
I mean, that's just the way it sort of is.
Yeah. No matter what it is, right? Like, it's going to need to be tested upon before you can say, like, all right, we know that this is demonstrably safer and more effective than opioids, because there's so much literature behind opioids already.
How they work, and we've been using them for a long time, and
the rules are in place, and like we're all set to go with opioids right now.
And the only real problem is that they work great when you have like your teeth removed and stuff, and you get a 1 to 2 week prescription.
Totally.
But using that thing that works and then patching it over to chronic conditions is really where the problem has come from. And like Carrie mentions in the chat, I was just reading that he says evolution must have been involved in our feeling of pain. You know, you touch something hot and you feel the pain. What about something like back pain? So that's a good point to bring up, so that's sort of where the issue comes from, right? You get a surgery where you have a super inflamed area where you're going to have pain. You take opioids, they block that. They sort of just block a lot of what's going on in your body, and it fixes it, right? Mm-hmm. But when you have chronic back pain, what ends up happening is that your nervous system is also connected to the rest of your body, obviously. So anytime you have a nerve impulse, you're also having a neurochemical response. So your body has this whole big organic response to pain, and the system of being in pain is sort of just this thing that develops. Mm-hmm. And using opioids doesn't really help with that.
Right.
But it's the only thing that we know to treat pain, so that's sort of just what happens.
Gotcha.
You know, that's sort of where we're at this point, where we know it stops this sort of pain, and it's well researched in the literature, and it works, but it's ineffective at sort of stopping this overall neurochemical problem that happens with chronic conditions. So where to go from there? Like I said, I've read a lot of stuff, but it doesn't really seem like there's a clear view of what our goal is and where we're trying to end up at.
Yeah.
In regard to this issue.
Yeah, it's not like other science where, you know, we've got a track that we're following, and, you know, we're making step by step incremental progress towards solving this problem. It sort of seems like this is just a problem, and nobody really knows how to tackle it. I guess the win-win situation, right, Tom, is if CRISPR-Cas9 can figure out a way to genetically alter us to not form a dependence to opioids, right? Like, because then you just solve both problems with one right there.
True. I can see where you're trying to go with that.
You know, like, instead of trying to find an alternative solution in the form of some pill or some way to, like, replace opioids, it's like, well, if we could just figure out how to make it so that people don't have this change brain chemistry when they start using opioids regularly, well, then that might be the way to win it. But I don't know if that's possible. I don't know enough about opioids to really know about that.
Yeah. I don't know if you'd be able to just change the ability to, like, form a dependence on it. Like, that sounds like it might be
too
above Cas9's pay grade.
Well, yeah.
You know, especially at this point in time.
Yeah, definitely above CRISPR-Cas9's capabilities, but I mean, maybe that is the direction, right? Maybe that's like
of where eventually it'll lead up to.
Yeah.
But yeah, I mean, I'm always trying to follow along with the news, and it's pretty interesting what some people are trying. I just recently read one article that what they think is the answer is like some sort of stimulation, like spinal cord stimulation, and once we perfect that it'll change everything.
Interesting.
I've actually tried a spinal cord stimulator personally, and it didn't really do much of anything for me. And it's just really interesting when you read things and the way they make them seem so like realistic and ideal and everything.
Yeah.
It's a lot of times so far off the ball and the mark when you read these medical type things, because they're just trying to say, like, paint the beautiful picture it might be.
Yeah.
Whereas it's oftentimes very different from what's actually happening.
Yeah. Well, I mean, this is what we talked about last week with the stem cell company, where it's painting this broad picture of like, this is a beautiful thing. You're never going to have to worry about your body degenerating.
But we're not even there yet.
We're not there yet. So.
Yeah. There's a lot of research that needs to be done.
Yeah.
So I know if somehow I could go back to when I was a younger person before this situation, I probably would have gone into researching into some sort of way of pain management and just trying to figure it out. But I don't think I want to go back to school as right now.
Not yet.
Not feeling it.
Not pulling the trigger yet. I told Kayla when I was drunk the other night that if I don't have something else going for me, then I might go back to school. Possibly.
We'll see.
I was drunk though, so I can't be held accountable for anything that I said.
You're going to study ancient Russian literature?
Yeah.
I think.
Well, that is all I think that we have to share with you guys this week. Thank you guys for watching. Like we said, if you enjoyed this content, please go to YouTube and subscribe to the channel and check out the other social media offerings that we have for you guys.
Yeah, and don't forget, each week we don't just randomly come up with these stories. We find out what is sort of the most popular stuff on various science outlets. And I think it would be cool if eventually we could have one or two stories always from our audience trying to pick the top ones.
I agree.
So that's eventually the goal. So don't forget to tag us on anything on Facebook, Twitter. That's pretty much it, right? Facebook and Twitter. Yeah. But yeah, tag us and stuff, whatever you see.
Yeah. Or Tom,
even if you don't read the article, if you see a headline and you want to throw it our way, let us know.
The third way, Tom, is they could email us.
You could email us.
trèScimail@gmail.com.
Yeah, that's not a bad way either.
Nope. Like we said, thanks for watching, guys. We will be back next week with more science news coming at you. Until then,